So we started out actually building the first Web3 smart contract automation protocol on Ethereum, and then of course on all other EVM-based chains. This market is basically a subset of the overall block space market. And as block space remains scarce and limited, the market really to automate stuff and to relay stuff is inherently limited by this. And so we were sort of like hitting the limits in order to grow the pie of all the other things we're building. We need to actually grow the pie of block space. We need to get more chains, more applications. This is then where we really saw rollups as the solution, how we can get that and how we can then help projects actually scale.
Welcome to Epicenter, the show which talks about the technologies, projects, and people driving decentralization and the blockchain revolution. I'm Friederike Ernst, and today I'm speaking with Hilmar Orth, who is the founder of Gelato, one of the leading rollup-as-a-service providers. Before I talk with Hilmar, let me tell you about our sponsors this week, though. If you're looking to stake your crypto with confidence, look no further than Chorus One. More than 150,000 delegators, including institutions like BitGo, Pantera Capital, and Ledger, trust Chorus One with their assets. They support over 50 blockchains and are leaders in governance on networks like Cosmos, ensuring your stake is responsibly managed. Thanks to their advanced MEV research, you can also enjoy the highest staking rewards. You can stake directly from your preferred wallet, set up a white label node, restake your assets on Eigenlayer or Symbiotic, or use their SDK for multi-chain staking in your app. Learn more at chorus.one and start staking today.
This episode is proudly brought to you by Gnosis, a collective dedicated to advancing a decentralized future. Gnosis leads innovation with Circles, Gnosis Pay, and Metri, reshaping open banking and money. With Hashi and Gnosis VPN, they're building a more resilient, privacy-focused internet. If you're looking for an L1 to launch your project, Gnosis Chain offers the same development environment as Ethereum with lower transaction fees. It's supported by over 200,000 validators, making Gnosis Chain a reliable and credibly neutral foundation for your applications. Gnosis DAO drives Gnosis governance, where every voice matters. Join the Gnosis community in the Gnosis DAO forum today. Deploy on the EVM-compatible Gnosis Chain or secure the network with just one GNO and affordable hardware. Start your decentralization journey today at gnosis.io.
Hilmar, it's super nice to have you back on. The last time we had you on this pod was beginning of 2023, which was really a different time.
Very different, yeah. Thanks for having me again. Glad to be here.
So you are one of the founders of Gelato. Last time we had you and your co-founder Louis on. It's been a while, so maybe give us a brief recap of the history of Gelato. And what's happened since early 2023?
Yeah, totally. So I think last time we were on here, we talked all about our shared history as well with you and the other folks at Gnosis. Of course, you were like early supporters of us at Gelato when we started back in 2019 originally. And I think 2023 was the year for Gelato where we really started to endeavor on our journey to scale Web3 and go all into the rollup-centric roadmap. And this was kind of like the starting point when we started researching and developing what is now one of the leading rollup-as-a-service platforms in the space. I think when we were on back then, we sort of started on that journey. And I think fast forward to today and like 1.5 years or so have passed, I think, since then, right? Feels like an eternity, of course. But now we have 40-50 rollups live on our platform. Huge sort of chains such as Lisk or Kraken's Ink chain on Gelato, among many other really great projects. And we really saw, I think, in general as a space, this sort of rollup-centric roadmap play out with any larger ecosystem or project or application now looking into launching their own chain. We of course continuously trying to find what is the best ways of achieving this. How can we scale Web3? How can we help scale these applications while remaining all the cool guarantees that Ethereum and other ecosystems sort of bring to the table? I think that's a pretty much a good summary.
I think we'll dive into kind of like rollups and sovereign rollups and native rollups and kind of like whatever rollups kind of like in just a second. Kind of back in 2023 and before that, kind of you guys mostly did relaying, right? Kind of it was kind of like a relayer network. So is that still going on? And what led to the shift towards kind of this rollup-as-a-service platform?
Totally. So we started out actually building the first Web3 smart contract automation protocol that really sort of got traction on Ethereum, and then of course on all other EVM-based chains. We are still running this service among our transaction relaying service, which is used by a lot of projects for their account abstraction, sort of bundlers and so forth. What we realized though at some point is that this market is basically a subset of the overall block space market. And as block space remains scarce and limited, the market really to automate stuff and to relay stuff is inherently limited by this. And so we were sort of like hitting the limits of these markets. And we were like, okay, we need to, in order to grow the pie of all the other things we're building, we need to actually grow the pie of block space. We need to get more chains, more applications, more block space. And this is then where we really saw rollups as the solution, how we can get that and how we can then help projects actually scale. Because an easy example, if you want to sponsor millions of transactions while still retaining like the security and censorship-resistance of like an Ethereum or some forth, like you can't do this on Ethereum, but you will go bankrupt. I think many people have tried, and so you need to get more block space. You need to create an abundance of block space in order to actually then achieve these sort of user experience benefits. And this is sort of how we transitioned into solving this fundamental problem first.
That makes a lot of sense in terms of kind of like why you decided to embark on this endeavor. So maybe let's set the stage by kind of talking about what you actually mean by a sovereign rollup, because kind of like when we kind of usually talk about rollups, usually we think about kind of like full rollups or validiums, and kind of meaning kind of like you have different parts of the consensus mechanism that kind of have to check in with base layers. So kind of in the full rollups, it's kind of the state and the data, kind of with data availability. And then in the Validium, it's kind of just the state periodically. What happens in a sovereign rollup? Because kind of like even the moniker sovereign rollup, it sounds like a bit of a conundrum, right?
Totally. And let me sort of, as a disclaimer before I start, say all of these definitions are highly complex. It's like it took also myself, like working on nothing else than rollups for over 2 years, a lot of time to really understand this. And there are settlement layers and rollups and so forth. And so let me try to maybe unpack and provide you with the definitions that I sort of
I would love that.
And a rollup for me is a blockchain that posts its blocks to another blockchain at its very core. And a blockchain really for me consists out of, in this case, a rollup blockchain consists for me out of a state. So it has state. Then it has a certain state transition function, which is, let's say, like the EVM. And then it takes in transactions through the state transition function to progress the old state to the new state, right? And this is how the blockchain progresses. Now, the cool thing about rollups is that you don't need to bootstrap your own validator set and come to consensus around a certain ordering of transactions. You can outsource this to another layer, which we call mostly the data availability layer, right? You can use Ethereum for this. You can post transactions as blobs to Ethereum. You can also use others like Celestia for this, which are sort of purposely built to only do that. And this is at the core really what a rollup is. You just post your blocks to another chain and they come to consensus around its ordering. Now, if you think about it, this is really all you need to have a rollup. you just need this sort of this rollup chain, and then you need another blockchain to do consent on the list of all those transactions. Where it gets more complex is now the bridging part. And there's this nice saying, it's like, it's all just chains and bridges at the end of the day when we talk about rollups. Why people now get confused about like, okay, isn't like if I talk about like a base right now, isn't base like a rollup? Yes, it is a rollup, but I call it an enshrined bridge rollup. So what does that mean? It means it has a rollup, so it posts its data to it, other data availability layer like Ethereum, but it also has an enshrined bridge to Ethereum, which we in this case call the settlement layer. And so what this means is that you can bridge in assets from Ethereum directly to Base, right? And you can use the funds on Base, and then you can move your funds out again. We call like trustlessly, with certain proofs that you provide back to the base layer, which in this case is Ethereum. And what the sort of like the unlock here, what is important for sovereign rollups is that sovereign rollups basically take an approach which is, okay, rather than having this worldview where we need this enshrined bridge to Ethereum, let's cut it out completely. Let's remove this enshrined bridge to Ethereum, and let's only have the rollup which posts its blocks to a data availability layer like Celestia in the case of the ABC stack, and therefore fully embrace like a more modular, decoupled way where we don't confuse and enshrine the bridge to the rollup. We just detach it and we treat the rollup separately. And then what we do is, rather than having this enshrined rollup, you can take any kind of modular interoperability protocol that you would like, for example, a layer 0, a hyperlane, or whatever you want. And you can use that instead to bridge from assets, not only from Ethereum, but you can bridge assets in from Solana, from Base, from Arbitrum, from Ton. And the unlock here, I think, why we have discovered this as being extremely valuable and actually potentially the future of how rollups will be designed, is that the current rollup stacks, like, and this is where we think like what rollups are, they were designed back then with this very Ethereum-centric worldview. It's like, okay, with Ethereum, we need to scale Ethereum. How can we scale Ethereum? By building these network extensions around Ethereum that look like Ethereum and have a bridge to Ethereum, right? But the world has progressed since then, and now there are chains out there, Base, Arbitrum, even like a Solana, a Ton, who knows, right? That have a lot of liquidity and a lot of users that people actually want to access as well. So it's not just scaling Ethereum. People just want to have a chain that scales but taps into all sorts of users, all sorts of liquidity. And this is what sovereign rollups sort of have. They're like, hey, rather than having this enshrined worldview and Ethereum at the center, and we are like the satellite that hovers Ethereum, we switch it around. We put the application in the center, and then Ethereum is basically the largest planet, like Jupiter orbiting the Earth, which in this case is your application. And this is sort of like conceptually speaking how I would view sovereign rollups.
As a physicist, I can tell you that Jupiter doesn't actually orbit the Earth, but
the sun in this case, of course. Yeah.
I take your point. I think I have lots of questions as to this. So maybe kind of like, let's start from a very basic understanding point of view. So kind of, I understand that you post the transactions into Celestia's data availability solution. In rollups on Ethereum, kind of you do two things, right? Kind of like you do, you post the data, but you also periodically post a proof that kind of the data takes you using the EVM, kind of like if you kind of take all the current state and all the data, all the transaction data, kind of it takes you to the new state, right? Does this function happen somewhere in sovereign rollups, or whom do I trust? Is my question.
So, and that's the sort of like unlock one has to have. So let's imagine, let's say, for example, let's take an example here. there is like a rollup on our rollup-as-a-service platform called Raya. They're pretty decent TVL. They're like a perp DEX. They use the arbitration orbit stack. They're on L2 to Ethereum, right? They have, I think, 98 or 99% of the entire TVL, what they have, is bridged in by a third-party bridges on the rollup. So by the way, they use the arbitration orbit stack, but all the funds, I think USDC is bridged in by a socket because they wanted to onboard their users not via Ethereum, which is pretty expensive, but via Base, Arbitrum, and so forth, right? Now, in this case, what they are still doing is they are still sending, as you say, like these sort of like hashes, these sort of stack commitments to Ethereum periodically because their stack is still built in a way where they have to settle Ethereum, but Ethereum provides them with zero security. Because Ethereum, if you have a rollup, an enshrined rollup to Ethereum, Ethereum doesn't secure your rollup. Ethereum gives you like consensus around the ordering of transactions if you use it for data availability, right? But the bridge, this notional settlement layer, like settling to Ethereum, the only thing what it provides you with is it provides you with a trustless bridge for the assets that are bridged into the rollup via the canonical enshrined bridge. And if you have, let's say, 99% of the assets bridged in via other chains, such as Base or Arbitrum, using, let's say, Socket or Layer 0 or so forth, then you get zero benefits and zero security from this chain. Because what is like why are rollups like why is this, like, let's say you have a sovereign rollup in this case, why would it be secure without sending these stack commitments to Ethereum, right? Because if you think about it, as I said at the beginning, was a rollup, you have inputs, you've got state, you've got a state transition function, and then you have outputs, right? And so the only thing you need is this ordered list of transactions that everyone can follow, right? You can just spin up a node. I can spin up a node. We all look at Celestia in this case. We see what is the ordered list of transactions for this particular rollup, and then we run a node. And then we know, okay, I know myself locally that, hey, this state transition function has been run correctly. And so I know that, okay, I received now $100 and you sent me $100, right? Ethereum, the Ethereum only needs a proof, like this bridge to Ethereum is like a light client, right? Because Ethereum cannot run a node for this rollup, right? So Ethereum doesn't know whether the state transition has been executed correctly. So what we do in order to like notify Ethereum to say, hey, Ethereum, you can accept back funds from this rollup to you, is we generate proofs that we post to this bridge smart contract, like in terms of like fraud proofs or ZK proofs, for example. And this then allows you to move assets back and forth. But this is only adding any benefit if you actually have funds in this bridge. And what is, I think, interesting, I think Martin did a great talk at DEF CON, Martin Köppelmann. And if you look at L2 Beat, for example, what you can see is that for all the rollups that exist, 60% of the funds of the TVL on all rollups are not bridged in by the canonical bridge. What this means is, like, if you sort of take this to the conclusion, is 60% of the assets are sovereign. So all the L2s on Ethereum right now are already, if you if you sort of think about it, 60% sovereign. They only are 40% Ethereum rollups, or only 40% of all the assets come actually from Ethereum. They might use Ethereum as data availability, right? But the assets in there don't inherit the security. And this, I think, is a very important point that people need to understand. And what we saw at Gelato is that we have a lot of chains that have 0% in these rollup bridges because they don't want to use it. They don't want to onboard people from Ethereum. They don't want to onboard assets that are issued on Ethereum. And so for them, it doesn't make sense. They just get overhead. They just have to pay costs to Ethereum. They have a bunch of legacy code that they need to use in these rollup stacks that deal with all like Ethereum related things like reorgs and so forth. And that's why taking the current trends to the conclusion would mean that actually what applications want is a way more sovereign construction than what they usually have right now.
So maybe if I reframe this a bit, do you think it's fair to say L2s as they currently exist are largely a meme, and you refuse to kind of pay for this mimetic security that kind of doesn't actually secure a lot of the assets in whatever rollup you're looking at?
Settling to Ethereum, if you do not use the bridge, is utterly useless, and you only pay and you don't get any benefits from it. And yes, this is then only a meme, and you can generate as many ZK proofs you want and post it to Ethereum. This doesn't add any security to the funds on your chain. So I fully agree with that. Yeah.
Okay, I have so many questions as to kind of how interoperability could or should work, but maybe kind of let's take it from the beginning. So maybe let's look at kind of how. So kind of I understand kind of what you mean by a sovereign rollup. So kind of let's look at how your rollup stack works and kind of how you achieve the pretty impressive throughputs that kind of you are achieving, and then kind of we can look at kind of like the wider Ethereum rollup ecosystem later and look how we could kind of untangle this to a certain extent. You guys recently launched Abundance, so kind of the ABC rollup stack, and what you can actually get with it is a 1 gigagas per second sovereign rollup solution. First of all, maybe kind of can you reframe the 1 gigagas per second kind of number? Because kind of like if you're not very, very hardcore in the gas weeds, what does that actually mean in terms of what sort of applications that could support?
Totally. For let's say for the end user, this might sound a bit cryptic, right? But I think why we use the gigagas measure or unit to measure throughput rather than the traditional transaction per second measure, I think that many people use, is because it really the blockchain throughput is limited by EVM. Blockchain throughput is limited by basically or measured in gas, right? So how much gas can we get into every single block? And that's why in Ethereum and so forth, the Bitcoin, there's these huge debates about block gas limits and so forth, right? Shall we do bigger blocks, right? There's all these discussions going on. And so what 1 gigagas, I think the easiest one to explain what an immense throughput gain this is to put it into perspective of what we currently have. So if you look at, let's say, Base, right, which is probably the rollup out there with the highest usage right now in terms of users and gas consumption, it currently has 0.017 gigagas per second worth of a throughput. And this is sort of also where the current Ethereum-centric rollup stacks clock out. We have customers on our rollup-as-a-service platform at Gelato, which build games. And I like games as customers because they're like, hey, if I have 100,000 users and I just put everything I want on chain and then everything is already full. They really try to max out the software. And they already clocked out at 0.018, 0.019 gigagas per second worth of throughput on some of the Ethereum stacks that we're using. And so what we do is we do a 100x improvement with ABC stack in terms of throughput compared to what you currently can do on Base or what this game could do. So this is a pretty big one. If you want to use the transaction per second sort of measure, we have some sort of I think you can translate to 50,000 transactions per second. But it really depends on the transactions, what they do, how much computation they consume.
In my head, kind of a small transactions around 100k gas. So kind of that's kind of yeah. So
yeah, that's a small transaction. Yeah.
So you're kind of 50xing the throughput
100x.
of.
They're yeah. 100. We can go higher than 1 gigagas, but roughly 100x. Yeah.
Okay, 100x. Okay, that is that's a lot. So kind of that means kind of you can kind of onboard games as an ecosystem because kind of that kind of commit a lot more transactions on chain and kind of can't pay the price point that many financialized transactions pay, right?
Yeah. So basically, we believe in a world of abundance. So abundant block space is necessary in order to actually create compelling applications for like a large number of users, right? And these games that we have, we are not talking about them having millions of users, right? They still have probably like thousands of users or something, but they're still already clogging out. But the games is, of course, one big vertical that we're also very bullish on that can actually bring in more retail people. But what we are, and we are like that we come from DeFi as well at Gelato, so we are always very focused on like, okay, how can we actually rather than everyone trading on Binance, how can we bring Binance really on chain? How can we really build like fully decentralized, censorship-resistant order books on chain, for example, right? And this is right now the current stakes are nowhere near close enough in terms of throughput to actually facilitate this, right? And I think this would be for me the biggest unlock. We see like with Hyperliquid and so forth how successful you could be if you actually sort of go in this direction. And what we are mostly bullish on here is actually enabling people without like having to horizontally shard via multiple instances for now, build like an on-chain Binance on a rollup. And I think this is for us the really exciting use case that this enables.
Why do you use Celestia as a data availability layer? Because kind of like if you look at Base, kind of they're clearly using Ethereum. So what's kind of limiting them to 0.02 gigagas?
So it's really the lack of decoupling. And so if you look at the last sort of centuries or like the last couple of years in software development, microservices architecture is really like a dominant sort of trend that you see, right? And what this means is that you decouple individual services from each other. So they run sort of like in silos, and you can improve them in silos, you can scale them in silos, you can make them resilient. If one fails, it doesn't impact the other. And you just make them so much easier to maintain because, if you change one thing here, you don't always have to change another thing here, right? The current stacks right now are pretty coupled. So every time you want to add something on, let's say, the execution client or so forth, maybe do improvements, you have to always look, okay, what about the fraud proof? What about the bridge on Ethereum? We need to upgrade it now in order to actually encompass these changes that we do here. So you really couple bridging with the actual like execution and the throughput, which is basically, if you have an enshrined bridge in your rollup, this is what you do. Like the Ethereum rollup stacks, they combine the rollup and the bridge into one. Basically what we do is we decouple them from each other and we make them isolated, which is what Sovereign rollups do. And through this decoupling, plus of course like a bunch of improvements that we do to the stacks, sequencers, and so forth, you can really gain these massive throughput benchmarks that we achieved. And this is really the secret sauce here. So decoupling things from each other, and then optimizing each specific thing. And when it comes to interoperability, the great thing is you just use whatever interoperability layer that you like. So many of the chains that are on Gelato use, for example, the layer 0 messaging protocol. Others use Hyperlane's permissionlessly deployable messaging protocol. And these messaging protocols are, the cool thing here is that you can define your own security. And we are strong believers in that, especially for start, like you don't need to overpay for security if you just get started as an application, right? If you just get started, you shouldn't pay $10,000, $50,000 per year to generate ZK proofs for like $100 in TVL, right? That doesn't make sense. So this should be like a progressive thing. You should have one modular interoperability protocol, and then as the more TVL you get, and the sort of higher the risk is on your chain, the more secure it should be. And so another great thing that we believe in is we believe that with like what ABC Stack is built for is we don't believe, like we think fraud proofs are the sort of very weird sort of middle ground that we're in right now. You sort of like everyone uses it, like not actually like most optimistic rollups actually still don't use them today, but it's kind of like this meme where it's like, hey, yeah, you get in, but okay, you can't, for getting out, you have to wait 7 days, and no one really waits 7 days themselves, right? Everyone uses like an operator like a cross on something, and a cross rebalances via Kraken and other centralized exchanges, and they are the only ones actually using the canonical bridge to wait 7 days and get out again. And so no one really wants to use them. And so what allowing modular interoperability solutions to be used means that you can instantaneously, just with attestations, bridge in from any chain to your chain, in and out in seconds, right away. And whenever ZK gets fast enough from a latency point of view and cheap enough from an approved generation point of view, you can just like flip the switch and go straight to ZK. So basically what we do is we leapfrog fraud proofs. We say, hey, just use for the beginning attestations. And then whenever you have high TVL and whenever ZK comes down, you just switch, because ABC stack is fully ZK forward compatible. And we don't, like as other stacks, we haven't built our own prover and our own ZK EVM from scratch in some weird programming language and so forth, what a lot of other people do. We just are compatible with Succinct's SP1, with RISC-Zero's proving system, with any other sort of Jolt ZKVMs that will come out of the market. You can use them directly, prove the entire ABC stack, and they can, it's again decoupling, right? They will work on the proving system, they will make it great. Celestia works on the DA, they will make it high bandwidth. We work on the client, we will make it high throughput, and combining all these things together in a super modular way provides the highest throughput, because everyone can focus on what they are good at.
Okay, I hear that. Let's talk about the security assumptions here. So kind of like, what you're rightly pointing out is that a lot of the security that's promised by L2s is not actually delivered by L2s. But I think kind of like I'm paraphrasing a bit meanly here, but kind of like if I were to kind of put my finger on the wound, I would say, okay, you're not promising any security, but you're also, you're not over-promising on security, but you're also not delivering anything better than kind of what the L2s who are over-promising on security are delivering, right? So let's kind of look at your security assumptions. So say I want to send a transaction to a sovereign rollup. Kind of I post that transaction to Celestia. What recourse do I have if for some reason kind of my data is censored? And what recourse do I have if my data is not censored, but somehow it's still not included? So so kind of what kind of like in the old rollup world kind of would be ideally kind of fraud proof. And I hear you that only works for bridged assets and so on. But so what are my security guarantees?
Yeah. So back to the previous point of what a rollup is, right? So the security of a sovereign rollup is exactly the same as the security of a enshrined bridged rollup. So the security is, okay, we need to all agree on a set of ordered transactions, right? And if we have the set of ordered transactions, everyone who's running a node can compute the new state based on these transactions, right? And it doesn't matter if you post, like, of course, there might be an argument to say Ethereum as DA is more censorship resistant than like another DA such as Celestia, right? And so this would be a security sort of trade-off that we made here in ABC stack, because Ethereum could be seen as more central resistance. I would agree it probably is due to like home staker, focusing on home stakers and so forth, right? But why do we do this? Why do we do this trade-off? Because Celestia is basically sort of what Ethereum wants to be in terms of its roadmap. It basically started with this clean slate when it comes to the rollup-centric roadmap. Celestia is built for rollups. Celestia says, hey, we are optimizing for 1 gigabyte blocks. And as soon as you post these transactions to Celestia, and Celestia, of course, still needs to scale. Celestia is still also not at the scale today to handle like 100 ABC stack rollups with 1 gigabyte per second. That is not the case, but they have a clear roadmap to achieve this, and are moving way faster than what Ethereum is doing. But the security is really coming from there. And now, of course, the other security, so the security is just the DA layer, right? And then everyone running a node. But then, of course, you have the bridging, right? So, and then, okay, well, how do you actually secure the bridging? This is you have to decouple these two conversations. And this is where, like, basically our whole point is that look at these bridges out there today, like Blast is the 4th largest rollup, Ethereum rollup, right, with $1.4 billion in TVL. And it has 2% of the assets are bridged in by the Ethereum rollup, which is secured by the fraud proof. All 82% are externally bridged in, or actually not secured by the bridge itself. For them, there's a caveat because they use this sort of vault system before that escrows all the ETH. But basically, the bridge itself is not even securing these funds. So you always have to look at who is securing the funds, and only and how many funds do they secure, and this is really the security you get. And so basically, most rollups today are already not really benefiting from the security from Ethereum. And so we just take it to the full conclusion, say, then just stop using it.
Then who's securing the funds in a sovereign rollup? So is it kind of the Celestia nodes, or who would you point to?
Yeah. So an interesting point here is that who is the asset issuer, first of all, is the question, right? For example, Ethereum issues ETH, right? And the ETH, who secures ETH in general is Ethereum, right? So if you would like to have ETH on your chain, then you will want to have a bridge to Ethereum, right? And if you don't want to have any other external dependencies in terms of security, you probably want a ZK proof-based bridge to Ethereum, right? And then if the ZK proof is so secure and you trust it, then it's sort of you have Ethereum security, right? For USDC, for example, USDC on Ethereum or USDC on Base is actually issued by Circle. So neither Ethereum nor Base provides you with any security for the USDC you hold on Ethereum or Base. It's solely a server somewhere at Circle, right, that provides you with that security. Now, for sovereign rollup, again, it depends who issues the assets. So if you issue the assets natively on the sovereign rollup, it's basically Celestia and everyone running the nodes who's securing these assets. So it's just a natively issued asset that you have, and there's a transaction that's sent to Celestia. It says, hey, I want to issue this asset, and there you see, now you got an asset on your sovereign rollup, and there's no external security dependency you have. Of course, if you want to bridge in assets from another chain, right? Let's say you have your own Base, and there's a natively issued asset on Base, and I think Base actually has 60% of all the TVL is natively issued on Base. It's most of it, right? So if you want to access these, let's say meme coin on Base, then of course you the biggest security assumption here is okay, the bridge. First of all, how do you get the message across from Base to your chain? And this is either in a tester, right? There's some nodes that are running full nodes, and they're checking the state transition on Base, and they're saying, okay, cool, it was done correctly. Here, I give you the asset. You trust those. It's kind of a multi-sig. Or in the future, of course, how it should be, and this is the end game, it's ZK. So you just have a ZK proof that then proves that the state transition on Base has been happening correctly. And then Base inherits the security, of course, as from Ethereum with its DA layer.
I understand. So kind of if you compare, say, Base and a sovereign rollup, so kind of the entity that kind of builds blocks on Base is the centralized sequencer, right? So kind of in effect, it's some sort of Coinbase entity, a single one that kind of, and I mean, in our rollups, this is the case to a certain extent. So some rollups kind of have a very limited list of allowed sequencing participants and so on, but kind of it's always a very short list that is curated by whoever kind of set up the rollup in the first place, which is why kind of truly decentralized sequencing is something that kind of all L2s on Ethereum or aspire to in some sense. You're rightly pointing out that kind of this is a very centralized function, but kind of can you compare and contrast with Celestia? So kind of if I rely on Celestia for something that is issued on a sovereign chain, so kind of nothing that's bridged or whatsoever. So kind of say I issue a coin on sovereign rollup 1, and that leverages Celestia. What exactly are my trust assumptions here as compared to an L2 on Ethereum that is admittedly not decentralized at this point?
Yeah, so I think maybe to unpack this a bit, like and focusing on the first part, which is like the centralized sequencing part. So most rollup frameworks today rely on this notion of the centralized sequencer to give fast pre-confirmations. This is also the same for ABC stack. So also in the ABC stack, you have right now a centralized sequencer model. Why do you want this? Because users, especially like in high throughput DeFi applications, they want to have fast blocks, and they want to have pre-confirmations, like preferably below 100 milliseconds, right? And we all know Ethereum takes rough 12 minutes or so forth to finalize. So only after like 12 minutes, you actually know that your transaction got included and didn't get reorged out or something, right? This is a long time to wait. Celestia actually in this case is already so like superior with their new upgrade. I think it's 6 seconds. And they have single slot finality because they use the dynamic consensus mechanism. So there you actually, after like you could already, like if you think about based rollups, right, that sort of basically circumvent the centralized sequencer censorship problem and like the equivocation problem. And then you could potentially even like build, like you can build base rollups today on Ethereum, but they are very unuser friendly. Even if you don't wait for finalization, wait 12 seconds. On Celestia, you could build it today, then you would wait like 6 seconds, but this is still too long. That's why you have decentralized sequencers. But we actually are very bullish on decentralized sequencing in general. And Celestia actually has on its roadmap to also have sub-second block times. I hope Ethereum will also get there at some point. And this will actually then enable this to be much more sort of pragmatic. Now, I think the second question you had was around the security of natively issued assets, right? And the security of natively issued assets on like a sovereign rollup, for example, are sort of twofold. It's a bit difficult to grab your head around it, but first of all, as I said, a rollup is a state transition function, and then the use state, right? And then you need the transaction ordering. So you have a finalized list of transactions that have been ordered. Let's say the first transaction is, hey, I want to issue this asset, right? And then everyone who's running this node basically runs the same state transition and knows exactly, hey, now the output should be that Frederica received these 100 assets, for example, right? The cool thing about the sovereign rollup is the security also sort of relies on like social consensus. It's a bit similar to Ethereum, right? In Ethereum, what we could do is if like Ethereum is also weird in that regard. Like in Ethereum, if everyone would now say, like then with the DAO fork, right? We said, hey, this transaction that happened, actually it shouldn't have happened. Let's all agree off chain and let's all update our client, and bam, after block 100, suddenly this hack didn't happen, right? This was like the security at the very essence, at the very core, was always like social consensus. You can just like fork, and then you have to rely on everyone so like participating. This is actually not the case for enshrined rollups, right? Because they have this enshrined bridge to Ethereum, so they can't just fork. If they would fork, then the bridge would have to be updated at the same time, right? So they have this sort of like dependency that makes them non-sovereign. And what a sovereign rollup is, by not having this enshrined bridge, is you could actually do similar forks when you do in Ethereum. So you can actually say, hey, if everyone agrees, we just update the client, and then this transaction that we included in our state transition function was actually is not included anymore, right? And you that's why sovereign rollups are not L2s, but you can think of them as sort of modular or virtual L1s, but without the need to come to consensus on the data. I know this is a bit tricky, and this also took me some time. But yeah, so social consensus at the very end is then still like the arbiter of what is like the security.
But do you think social consensus is a good thing to kind of be relied upon kind of as a default? So I agree kind of that it worked once for Ethereum, but it was also a very tight-knit community. There weren't kind of like the stake was way smaller than it is today. Kind of there was a very there was a very strong social coherence about kind of condemning the acts of the DAO hacker and so on. So do you think this is tenable kind of for future use?
So like Ethereum is still like the same, right? So it's all like deep down, it's all social consensus when you drill down in the blockchain world. In practice, the social consensus is highly restricted. For example, it's another like, of course, it's an exaggeration, but Ethereum, like you can argue that Circle or like Ethereum or Ethereum settles to Circle and Tether, right? Because a lot of the assets issued in Ethereum are actually issued by Circle and Tether, and they control such a vast amount of TVL on the chain that if Ethereum wanted to fork in order to do something, and Tether and Circle says no, we won't support it, then basically suddenly a huge chunk of the TVL
I
would
agree.
be
Kind of Circle and Tether would be kind of the kingmakers to kind of decide which fork is the real one. Yeah.
And so they are part of the social consensus, right? And this is the same for a sovereign rollup. As they're similar to an L1, if you have Circle issuing funds on the sovereign rollup, or if you have certain bridge operators that are issuing tokens based on other tokens that are locked on base, for example, on this rollup, then they will equally be an arbitrator in this whole sort of fork choice rule and would say, hey guys, actually, we don't support this because this is somehow acting malicious or something. So as these chains are always sort of social consensus at the very bottom, you always have this reliant, but you don't want to have this be one party, of course, right? You don't want to have this maybe be just Circle, but you want to have this to be a wide community of everyone in general. And then as long as you have this, you get the robustness of something like Ethereum.
Another question as to kind of the robustness. So kind of on Ethereum, assets are secured by Ethereum, right? So if you look at sovereign rollups, assets are in that sense kind of secured by Celestia and the Celestia stack. If you kind of run 100 sovereign rollups on the Celestia stack, don't you think you'll kind of overload the security that kind of Celestia with a base token kind of offers?
Yeah, so Celestia is in a sense a bit different to Ethereum, right? Because we are talking only about like DA right now. Celestia will have at some point ZK accounts, which is like a sort of ZK verification system as well. But when you talk about the scalability, so the scalability of Celestia is really about the bandwidth of how much data you can send to it. Yes, for sure. If we would have, I think, 1,000 ABC stack rollups a day that just send a ton of data to Celestia, it will probably be full. But it is already 2 to 4 times, I think, more has higher bandwidth than Ethereum has today. And it is sort of increasing that bandwidth at a pretty rapid pace with a roadmap to 1 gigabyte blocks. And so Celestia for us is right now the only actual alternative for this sort of rollup-centric roadmap that we are seeing in the space. And I hope Ethereum sort of will accelerate and will also provide it, because of course the more bandwidth there is, the better, right? But in general, bandwidth, of course, is limited right now on these networks, and so will then also be the throughput of the rollups. However, that's why you do have these sort of data availability committee systems, right? Let's say if it would be too expensive to post data to both Ethereum or Celestia, then you have these committees that sort of post only hashes and not all the data to Celestia, and so you can get additional scalability benefits at the cost of some trust assumptions, of course. But yeah, so these are the bottlenecks. But this is where like this decoupling, we are optimizing for this decoupling where, hey, Celestia, I let you guys cook, you'll figure this out. And like we focus on actually making sure that the rollup itself is as scalable and secure as possible.
So you already referred to this a bit earlier in the episode. So my co-founder Martin gave a talk at DevCon this year talking about Ethereum's need for native rollups. Kind of explaining that kind of the current rollup space adds limited security, as you have already pointed out, and also kind of fragments liquidity because bridging between different rollups, complete mess, as you have also pointed out. So kind of his solution was to say, okay, why doesn't the Ethereum community kind of introduce Ethereum endorsed rollups that kind of all work in the same way, where kind of we could say, okay, valuable assets are issued on Ethereum, they're kind of bridged into the rollups, they can kind of rely on the security guarantees provided by Ethereum for both bridging back to Ethereum and bridging to another rollup and so on. You saw the talk, right? And I assume you also kind of listened to the Laura Shin debate with Justin. What are your thoughts?
Yeah, so first of all, I think I really enjoyed Martin's talk, and I really like his intrinsic motivation to try to push the Ethereum community further and try to resolve issues and proposing alternatives. So I definitely applaud Martin for doing so, and he's been a steward of Ethereum for a long time, and I definitely deeply respect him for this. I think for me, what his proposal is addressing are two things really for me. Like there's no silver bullet, of course, right now to just solve interoperability, right? How do you solve interoperability is you need like fast and cheap real-time proving, right? If we have this, then like interoperability is cool. And I hope at some point the silver bullet comes around the corner and it's all there. But it will take some time, I'm sure. So what is proposal for me is more so of addressing is the value capture and the incentives. If we look at, like, I think what he really sort of also deeply means is that right now we have like the optimism ecosystem, we have the arbitrum ecosystem, we have the Polygon ecosystem, we have the Sync ecosystem, right? And they're all building these sort of clusters and all the value really is being captured by the rollups, right? There's barely any value that trickles down to Ethereum. And this is kind of like where I feel Ethereum finds itself in an innovator's dilemma, where Ethereum there used to be this meme like ETH is money. And yeah, there's so much like this pristine scarcity of the Ethereum block space is great because everyone will forever use Ethereum. And the more people want to use Ethereum, the more they have to pay. And the gas fees just go higher and higher and higher, and we just pay more and more and more, and ETH gets burned, and this is great, right? And it worked, right? For a time we were like deflationary. But then everyone was like, hey, we don't want to pay $100 for transactions, let's build rollups. And suddenly all these transactions, all these priority gas fees and so forth, they don't come to Ethereum. All this MEV, it's not leaking to Ethereum anymore. It's now on the rollups. And of course, this means that Ethereum, this is what I meant with the innovations dilemma, is at a pivotal point right now. So we have to decide, what do we want to do? Do we want to have this layer? And this is sort of maybe also where I deviate a bit for some opinions of others, but Ethereum for me has to decide, do we want to be a platform that caters exclusively to rollups, which I think for me also means that it has to be fine giving up a lot of value to rollups, and it has to optimize only for these rollups and like high bandwidth DA, cheap, fast ZK verification, right? And then actually nothing else. All the old legacy L1 state is sort of like just like technical debt at this point. Or do we want to focus on actually creating more L1 state, like scaling L1 and execution, having apps built on the L1 itself to actually capture all the value, right? Because for me, like based rollups and like enshrined rollups is a cool concept. And what Martin tries to do here is he says, hey, let's just have based rollups. We have this Ethereum deployed rollups where everyone can build on. There are plenty of them, so there shouldn't be any scalability issues for foreseeable future. There will always be at some point scalability issues, but for foreseeable future, we should be fine. And like all the sequencing, priority fees, MEV, and whatnot all goes to ETH, right? And now we are back where we were. Like everyone just builds on ETH, but just more scalable, right? And this indeed would lead to ETH, the asset, actually being sort of way more attractive in like the short to medium term again. I agree. But And so that makes sense. It's a good proposal in that sense for if you have this lens on. But what my lens is on, like or like at Gelato, what we sort of believe in, we are mostly catering to actually application developers and them. And if I look at the incentives here, is that if I look at the incentives, they clearly tell me that liquidity users, MEV, and so forth will go to the ecosystems and the applications that are actually sort of building and investing all the resources in, right? Base invested tremendous amount of resources in Coinbase invested tremendous amount of resources in Base to make it what it is today, right? And now they actually are slowly reaping the benefits of it. And why would they want to not capture it? Why would they want to give it away to Ethereum, right? So what we would need is we would need to recruit an array of altruistic developers that see Base and see the value they can capture, but decide not to capture it and give it back to Ethereum, right? And I think this is like the dilemma Ethereum sort of faces. If you look at the incentives, you will notice that I don't think this is a likely outcome. But in this, like taking this to conclusion, you still wanting to serve all these rollups, and you want to position yourself as like a key player in this market, and you want to have like nice bridging with for Ether your asset and so direct it there. You should maybe embrace. This could be one way, but you might want to embrace like a slightly different model, which is close to like Celestia, where Celestia says we don't have any state on Celestia. You can't actually build applications on Celestia. So it's just like a super high bandwidth DA layer. And then what we do is we focus on very efficient, cheap ZK verification. So the customers of Celestia are exclusively rollups. Whereas on Ethereum, there's like sort of rollups, but only rollups that now like should pay everything to ETH, and then still applications, right? This is like this weird middle ground. And so, yeah, I think it's a good proposal. I like his idea. But I don't think the incentives are there for developers to participate in helping.
But if Ethereum kind of were to come out and say, look, we see what all of you guys have done there with kind of these different rollups, and we see that this and this and this actually are super nice features, and we will kind of use all of the work that you guys have collectively done with VC raised money and kind of synthesize an Ethereum endorsed rollup of that sort. I mean, kind of, you don't actually have to reinvest all the money that's already been invested because a lot of the learnings are out there, and you can kind of just cherry pick, right? So kind of like say it would cost 10 million, 20 million, 50 million to kind of deploy 128 Ethereum endorsed rollups on top of Ethereum, right? That would undercut the entire current L2 system, right? So because if I'm a dev, why would I deploy on Arbitrum or Base or wherever if I can kind of deploy on the Ethereum endorsed L2 that kind of interoperates super nicely with all the other L2s, where I don't actually have to have the headache of kind of liquidity fragmentation and so on. Do you think kind of if the Ethereum community were to come out with that admittedly somewhat aggressive move, do you think that still holds? Kind of if they say, look, thank you for innovating, we'll take it from here.
So there's also a lot to unpack here. We got like interoperability and who gets interoperability and difference between like atomic, like L1, L2, composability and so forth. So there are like a lot of nuances to what Ethereum can offer versus others and so forth, but I don't want to go into all of them. But just from a high level point of view and an incentive point of view, I actually made a tweet this morning about it because I rewatched the Martin's talk before our conversation here. And I think what if you create incentives for developers to build the next base as a native rollup on Ethereum, then I do see this happening. This could then happen, right? How would you actually do this, right? You would need to completely go away from the scarcity mindset. You would need to completely go away from the ETH's money. Like, we need to now extract all the value mindset. Ethereum needs to start from scratch and say, like, okay, revenues 0, cost high. We now issue even more ETH. We say we pay for your rollup cost, we pay for the ZK verification, we incentivize liquidity to come into these rollups. We build this platform and incentivize it with a massive program, like what OP is now doing with, for example, all the OP stake rollups, right? They get massive incentives to join the OP cluster. You need to compete and like pay, I don't know, $40 million to these rollup projects that want to launch to these big exchanges if you want to get them on your platform, right? If Ethereum would be as aggressive to say, okay, we are doing this, and all the value will leak to you for now, and then maybe in 10 years or so, right, we will start like taking a small cut on like the MEV and whatever, right? And so it's just a long-term play. Then I would say, yes, this is a compelling story, because the incentives for projects to develop in a native rollup on Ethereum are there. If not, then the incentives are not there, and then the technical benefits that this brings versus just having a sovereign rollup, which can also generate ZK proofs, which can also interoperate with the other chains, is not that strong. And so, yeah, I feel we need to go aggressive, and I would like to see that. I'm all for it.
You're all for aggression. Fantastic. So maybe let's talk about, say, kind of this vision plays out, or kind of even L2 stay as they are, and they kind of they slowly become decentralized and kind of make good on the promises that kind of have been there for a long time. Where do you kind of see different sorts of applications kind of run in the long term, right? Because I think in this space, there's often this idea of kind of decentralization is great and so on, but kind of like obviously decentralization also means redundancy in some sense, and kind of like making each part replaceable and so on. So kind of there's a lot of overhead that comes with true decentralization. So and a lot of people don't appreciate that decentralization in itself is not a value, right? It's kind of like what you can, in principle, kind of reap from it as rewards. How do you think different applications will group themselves onto different blockchains or rollups or sovereign rollups according to what their security needs are, rather than kind of tribalism or kind of where they're incentivized to deploy and so on? Because these incentives, they can't go on forever, right? At some point, kind of they will have to be recouped, or kind of VCs will no longer kind of fork out for kind of incentivizing behavior that's not going to be rewarded in the long term.
For sure. And yeah, maybe to the point you mentioned with like decentralization is what that means to Android. I think what the property is that blockchains provide is censorship resistance, right? So this is, I think, what decentralization provides you, which I think in today's age is extremely, extremely valuable, right? If you look at like how we are getting censored in the EU, it's crazy, right? And so censorship resistance will become, I think, more and more important. And the security, by the way, as long as if we have censorship resistant DA layers, and then if we have ZK, then the only real benefit that like a decentralization will provide is censorship resistance, because like the verifiability you can get from ZK, right? You can have a centralized sequencer with ZK that works, but they can of course censor you, right? So centralization is definitely still important. That's why decentralization is also still important on some level, like the DA layer, for example. Now, how do I see these applications develop? For me, there are two camps of applications that we at Gelato sort of have in our mind. One is like probably where the majority of like long tail applications will be, and these are not like the hyper sort of DeFi native use cases. They will probably not care about censorship resistance that much. And they're like, what I want is great UX, high throughput, low costs, all of that, right? And what is that? It's like centralized sequencer, 1 Gigagas. You go out there, kiddo, and you just get these users onboarded, right? So I think there will be huge huge array of users, projects that will do that because it's totally fine for them. They're not in the business of censoring their users, right? And then on the other hand, I think there will be this new financial, decentralized, fully censorship-resistant a platform that will be built, the on-chain Binances, the on-chain everything financial, where you don't want to have one party controlling the sequencing and so forth, and like the US won't interact with the centralized sequencer of Germany and Switzerland and so forth, or Citadel of Deutsche Bank and so forth. There you need a credibly neutral censorship resistance platform, but that can be super scalable. And this will be huge in terms of value and so forth. And I think there we will see rollups, like we will see rollups handling that, but they will have to be built in a way more sort of like censorship-resistant manner. Potentially a base rollup with super fast block times from the L1 or some sort of pre-confirmation layer in between. So what I believe is, in general, like answering the question about clusters, I believe we will soon see a big movement. That's why we are investing our resources in it, into sovereignty. Projects will want to be as sovereign as possible. Applications want to reap all the benefits of what they create from the sequencing, from the users, from the TVL and so forth. They want to be independent. They want to use modularity to their advantage by do custom block building and so forth. They don't want to be limited in their configurations of what they want to do. And so they want to be highly interconnected with ZK and sovereign in order to really reap the benefits of high scalability. This is so like where we see it, but in the short to medium term, you will have these clusters like the superchain cluster, you will have the Arbitrum cluster, you have the whatever cluster. So it will be a weird time, but eventually I think the end state is sovereign chains, all interconnected, like in the Web 2, right? Your server is not part of a cluster, right? If you build an application, you might be in a data center, but your server is not part of the cluster. You are a sovereign application, and you have one protocol to interact with another, like HTTP or something, to communicate, and APIs and so forth. But you are still your own thing, and I think Web3 will look similar.
What does it mean in terms of kind of Gelato and the ABC stack for you in the next, say, 1 to 2 years?
Yeah. So, as I said, ABC stack is basically sort of like what we believe the future will be. Our learning of the past 2 years working with hundreds of rollups and customers and listening to what they actually want. And so what we are really looking to build is how can we build the next on-chain Binance? How can we build the next on-chain Twitter, but fully censorship resistant and highly scalable? And how can we build a platform to sort of facilitate this? And there's this platform component, which is of course like the rollups-as-a-service, like this needs to be serviced and scalable and like very easy to deploy. But then there's also the censorship resistance and decentralization part of it, right? And how can you actually sort of facilitate this? And this is also where like abundance at some point comes in to the picture, which is kind of like the overall sort of brand of ABC stack. And yeah, these are the questions. How can you build highly scalable, censorship resistant, sovereign rollups? And yeah, abundance is what this will be.
Thank you, Hilmar. So if there are people kind of who want to try out the stack or kind of build a sovereign rollup, how can they find you guys?
Yeah, for sure. So you can check out at Gelato Network on Twitter at abundance_XYZ for abundance. You can deploy a 1 Gigagas ABC stack testbed today on Gelato. Just go to ras.gelato network, 1 click, you got it. Mainnets will go live in January. So we'll have the first mainnets live. Super excited about this. Team is locked in to facilitate this and get it shipped. And yeah, just follow us there, and we'll do some tweets.
Cool, fantastic, Hilmar.
Thank you.